Hello everyone, welcome to my channel. Let's discuss 26th problem. What is the 26th problem? Prove that root 3 is an irrational number. So we have to prove that this root 3 is an irrational number. Let's prove it. To prove root 3 is an irrational number, first of all we have to assume that root 3 is rational number. Let us assume that root 3 is rational. Root 3 is rational and it is equal to root 3 is equals to a by b, where a and b are co-prime numbers. Next, bring this b to the left side becomes root 3 into b is equals to a. Now squaring on both sides. Root 3b whole square is equals to a square. Root 3 whole square is 3 and b square is b. So it is equals to 3b square equals to a square. Send this 3 to the right side. Now it becomes b square is equals to a square by 3. That means here a is divisible by this a square is divisible by 3. So a square divided by 3. So a square is divisible by 3. Is divisible by 3. When a square is divisible by 3, so a is also divisible by 3. Let us assume that when a is divisible by 3, the quotient is some c is some positive integer. When a is divisible by c, let us think that the quotient is c is some positive integer. Now send 3 to the right side. Now a is equals to 3c. Again squaring on both the sides. A square is equals to 3c whole square. So a square is equals to 9c square. So in place of a square, we know that a square is equals to here. Where is a square? So a square is here equals to 3b square. So in place of a square, write 3b square. So it is equals to 3b square is equals to 9c square. Bring that 9 left side. 3b square is equals to 9 is equals to c square. So we can cancel here. 3 ones are 3 threes are. Now it will be equals to c square is equals to b square by 3. That means here this b square is divisible by 3. When b square is divisible by 3, b is also divisible by 3. So we can write like this: b square is divisible by 3. So b is also divisible by 3. That means here both A and B are divisible by 3. So here what we got here, A is divisible by 3, and here we got B is also divisible by 3. So when A and B are divisible by 3, A and B are not co-prime numbers, right? So we can say that both A and B are divisible by 3. So A and B are not co-prime numbers. That means this is contradiction to our assumption. We have assumed that A and B are co-prime numbers. So this contradiction has arisen because of our wrong assumption. What was our wrong assumption? That root 3 is rational number. So here root 3 is not rational number. So therefore root 3 is irrational number. It is not rational number. So this is the solution for this question. Next 26b question is state true or false for each of the following statements. Justify each case. So what is the first question is given? 2 into 3 into 5 into 7 plus 7 is a composite number. And second question is 2 into 3 into 5 into 7 plus 1 is a composite number. So we have to say whether these are composite numbers or not, true or false, and if it is true, why it is true, and if it is false, why it is false. So let's write what is given. The first one, 26b question. What is the first one given? It is given that 2 into 3 into 5 into 7 plus 7 is a composite number or not. First of all, so here this 2 into 3 into 5 is one term and 7 is another term. So from these what we can take common, let's take 7 common. So if we take 7 common, we will have 7 out of the bracket. Now inside the bracket we will have 2 into 3 into 5 plus here 1. So we will have 1 here. So 7 into, otherwise yes, 7 into, we can write inside the bracket 2 3 is a 6, 6 into 5, 30 plus this one, 31. So now it can be written as 7 into 31. So when a number can be written as product of two numbers other than 1 and itself, it is a composite number. So we can write like this, as the number can be expressed as the number can be expressed as product of two numbers. Product of two numbers except 1 and 2, 1 and itself. So it is a composite number. So this is the justification for the first question. So what is the second question given? The second question given is this one. What is that? 2 into 3 into 5 into 7 plus 1. So let's write this one. 2 into 3 into 5 into 7 plus 1. 2 into 3 into 5 into 7 plus 1. So here this this can be written as 1 into 2 into 3 into 5 into 7 plus 1. Here for both these terms nothing is common except 1. Except 1 nothing is common. If you take x 1 also common, you will get the same result after multiplying. What I mean is, for example, if you multiply these numbers, what do we get? So 1 1 into 2 2 2 3 is a 6 6 5 is a 30 into 7 plus 1. How much will get? 30 into 7, it will be equals to 210 plus 1. Now it is equals to 211. As this 211 cannot be written as product of two numbers except one and itself, so it is not a composite number. As 211 can be written as cannot be written as product of two numbers. Product of two numbers except one and itself. It is not a composite number. So this is the reason for this one. As we cannot express 211 as product of two prime numbers, two number, it is not a composite number. Next question is 27th question. Obtain the zeros of the polynomial 7x square plus 18x minus 9. Hence, write the polynomial each of whose zeros is twice the zeros of the given polynomial. So first of all, we need to find the zeros of this polynomial, and we have to find one more polynomial whose zeros are double the zeros of this polynomial. So first of all, let's find the zeros of this polynomial by factorization method. So what is the polynomial given here? So it is the polynomial given is here is 7x square plus 18x minus 9. So let's find the zeros of this polynomial. For that we have to take p of x value 0. To find the zeros of this polynomial, we have to make p of x value 0. So 7x square plus 18x minus 9 equals to 0. So to factorize it, we have to multiply the coefficient of x 7 and constant term minus 9. So let's multiply 7 and minus 9. 7 into minus 9 is equals to minus 63. and the factors of 63 must be such that if we multiply we should get minus 63, if we add we should get middle term 18. So what are the suitable factors? Twenty-one into minus 3. So 21 into minus 3 is minus 63. 21 plus minus 3 is equals to plus 18. So plus 21 and minus 3 are suitable factors. So let's rewrite the middle term like this: 7x square. Now this 18 can be written as 21x minus 3x minus 9 is equals to 0. So from the first two terms you can take 7x common. If you take 7x common, so here we will have one more x, and here we will have 3. So from the next two terms let's take minus 3 common. If we take minus 3 common, here we will have x, and here we will have plus 3 is equal to 0. Again we can take x plus 3 common here. So if you take x plus 3 common, so we will have 7x minus 3 equal to 0. So we can write it as x plus 3 is equals to 0, or 7x minus 3 is equals to 0. Here if you send plus 3 right side, becomes x is equals to minus 3, and here send is 3 right side, 7x is equals to 3, and send 7 right side, x is equals to 3 by 7. So here the zeros are alpha is minus 3, so beta is 3 by 7. So alpha is minus 3 and beta is 3 by 7. So we have to find a quadratic polynomial whose zeros are double of this one, means 2 times of alpha. So minus 3 into 2 is equals to minus 3 into 2 is equals to minus 6. Next 2 times of beta. 2 times of beta is 3 by 7 into 2 is equals to 6 by 7. So we have to find a quadratic polynomial with these zeros. For that we need to find the sum of zeros and product of zeros. Sum of the zeros: 2 alpha plus 2 beta. So 2 alpha is minus 6, 2 beta is 6 by 7. So let's multiply with 1. Otherwise, to make the denominators equal, minus 6 by 7, sorry, minus 6 by 1, we have to multiply with 7 by 7 to make the denominators equal. So it is equals to minus 42 by 7 plus 6 by 7. So minus 40, both denominators are equal, right? So it is equals to minus 42 plus 6 whole by 7. So 2 alpha plus 2 beta, sum of the zeros is equals to, it is minus 36 by 7. So sum of the zeros is minus 36 by 7. Now what is the product of zeros? 2 alpha into 2 beta. So 2 alpha is minus 6 into 2 beta is 6 by 7. So if we multiply, what do we get here? Minus 6 into plus 6, it is minus 36 by 7. So we got same result, product of zeros and sum of the zeros is 7. Now we can write the polynomial as, what is the formula to find the polynomial? P of x is equals to k of x square minus x of sum of the zeros 2 alpha plus 2 beta, product of zeros 2 alpha into 2 beta. So k of x square minus x of, what is 2 alpha plus 2 beta? It is minus 36 by 7 plus, what is 2 alpha into 2 beta? It is minus 36 by 7. Now k of, so this x square by 1 multiply with 7 by 7 to make denominators equal. Next here, what do we have? Minus x into minus 36 is equals to plus 36x by 7. Now it is equals to minus 36 by 7. Now k of x square into 7, 7x square, 7x square by 7. Now this is 36x by 7. Now this is 36 by 7. Now denominators are equal, right? You can add the numerators directly. So you can write k of 7x square plus 36x minus 36 whole by 7. Now if you take k value 7, so if you take this k value 7, the 7 and 7 gets cancelled. So if k value 7, the polynomial will be equals to 7x square plus 36x minus 36 if k value is 7. So this is the answer for this question. Now 28th question. What is the 28th question? Solve the following system of equations graphically. So the equations are 2x minus y minus 2 is equals to 0, and this one minus 4x plus y plus 4 is equal to 0. Also find the absolute difference between the ordinates of the points where given lines cut y-axis. So this is the second part. First of all, let's plot these lines on the graph. So what are the equations given here? The first equation is 2x minus y minus 2 is equals to 0. Second equation is minus 4x plus y plus 4 is equals to 0. So 28th question, right? Okay. So let this equation 1 and let this equation 2. For both the lines, we have to find at least two plotting points. So let's take from equation 1. So what is equation 1? 2x minus y minus 2 is equals to 0. Send minus y to the right side. Now what do we have? 2x minus 2 is equals to y. Otherwise, we can write it as y is equals to 2x minus 2. Let's take the table of plotting points. X, y, x comma y. So if x value 0, so what do we have? If x value here, from here, so y is equals to 2 into 0 minus 2. So y is equals to 2 into 0 is 0. So 0 minus 2. So now we'll get y value minus 2. So the plotting point will be 0 comma minus 2. Now if you take x value 2, let us take x value 2. If you take x value 2, so what do we get? Y is equals to 2 into 2 minus 2. So y is equals to 4 minus 2. So y is equals to 2. So we'll get y value 2. So the plotting point will be 2 comma 2. Yes, now let's take equation 2. From equation 2, so what is equation 2? Minus 4x plus y plus 4 is equals to 0. Send minus 4x and plus 4 right side. It becomes y is equals to plus 4x minus 4 is equals to minus 4. That's it. Now take the table x, y, x comma y. At least we need 2 points, right? So if x value 0, what it becomes? So here, from here, what you can write? Y is equals to 4x, means 4 into 0 minus 4. So y is equals to 4 into 0, 0 minus 4. So y is equals to minus 4. So y is equals to minus 4. The plotting point will be 0 comma minus 4. Next, let's take x value 2. So let x value 2, what it becomes? Y is equals to 4x, means 4 into 2 minus 4. So y is equals to 4 into 2 is 8. 8 minus 4. Now y is equals to 4. So y value 4. Now the plotting point will be 2 comma 4. That's it. So let's plot these points on the graph. Let's take the graph sheet. So here 0, 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, minus 1 here, minus 2, minus 3, minus 4. Okay, let's see the plotting points. What are the plotting points here? So here 0 comma minus 2, 2 comma 2. So 0 comma minus 2, 2 comma 2. So where is the 0 comma minus 2? Here. So this is 0 comma minus 2. 2 comma 2. Where is the 2 comma 2? Here. So draw a line passing through these. And the second line, what is the second line? Second plotting points. 0 comma minus 4, 2 comma 4. 0 comma minus 4, 2 comma 4, right? 0 comma minus 4 here. So this is the 0 comma minus 4 here, and 2 comma 4. Where is the 2 comma 4? Here. Let's join with the line. So where are the points where these lines are meeting? Now it is at 0 comma minus 2. Now it is y-axis. It is equals to 0 comma minus 4, and we have to find the difference of the ordinates. Ordinates means y coordinates difference. So difference is always big number minus small number, right? So what is the difference of these ordinates? Difference of ordinates. So big number is at minus 2, minus of minus 4. So it is equals to minus 2, minus of minus 4 is plus 4. It will be equals to plus 2. So the difference between these ordinates is plus 2. So this is the answer for this question. Next, 29th question is, so what is the 29th question? Find the relationship between x and y such that px comma y is equal distance from the points a 3 comma 5, b 7 comma 1. Hence write the coordinates of the points on the x-axis and y-axis which are equal distance from point a and b. So first of all, we have to find the relationship between x and y. Then we have to answer the second part. What is the second part? We have to find points on x-axis and y-axis which are equal distance from point A and B. So if a point is on x-axis, y coordinate is 0. If point is on y-axis, x coordinate is 0. So let's find the relationship between these. So p coordinates are given, px comma y, and a coordinates are given. What are the a coordinates? 3 comma 5, and b coordinates are given 7 comma 1. So this p is equal distance from a and b. So This P is equal distance from A and B. So let us think this is P, x comma y, and it is equal distance from A point, which is 3 comma 5, and equal distance from B point, which is 7 comma 1. So that means when P is distance equal distance from A and B, now we know that PA distance will be equals to PB distance. So let's find the distance between P and X, P and A, P and B. So what is that? What is the formula? Distance formula. So the distance formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square. Y2 minus y1 whole square. So let's apply this formula for this P and A. So PA distance will be 3 minus under root of 3 minus x whole square plus 5 minus y whole square equals to under root of PB distance 7 minus x whole square plus 1 minus y whole square. So both the sides square roots gets cancelled. If you squaring on both the sides, if you square on both the squaring on both the sides, then the square roots will get cancelled. Now we will have only these 3 minus x whole square plus 5 minus y whole square equals to 7 minus x whole square plus 1 minus y whole square. Now apply a minus b whole square formula for all the things here. So here let's apply this for the first one here. A square plus b square minus 2ab means 3 square plus x square minus 2ab minus 2 into 3 into x. Now let's apply this formula for this one. 5 square plus y square minus 2ab minus 2 into 5 into y equals to, now let's apply the formula for this one second, this one. So 7 square plus x square minus 2ab minus 2 into 7 into x plus, now for this one 1 square plus y square, so minus 2ab is minus 2 into 1 into y. So now this one 3 square is 9 and this x square, minus 2 into 3 into 6, 3 into x minus 6x. Now 5 square is 25, y square is y square. Next minus 2 into 5 into y minus 10y. So here equal to 7 square is 49 and x square. Next this is minus 14x plus here 1 square is 1 and y square is y square, and this is minus 2 into 1 into y, so minus 2y. Now if you see the left side and right side, left side we have x square, right side we have x square, left side we have y square and right side we have y square. We can cancel when they have the same sign. Now add the like terms. So 9 plus 25 is 34 Next, what do we have? Minus 6x and minus 10y. Minus 6x minus 10y equals to right side 49 plus 150. Next, minus 14x minus 2y. Minus 14x minus 2y. So send 34 right side. Bring this minus 14x minus 2y left side, and this 34 right side. Now on the left side we have already minus 6x minus 10y. So if you bring minus 14x left side, it becomes plus 14x, and if you bring this minus 2y right side left side, it becomes 2y. Now on the right side we have 50. If you send this 34 right side, it becomes minus 34. Now now minus 6x plus 14x is equals to 8x. Next, minus 10y plus 2y is minus 8y is equals to 50 minus 34, 16. So from here you can take 8 common. If you take 8 common, x minus y is equals to 16. Send this 8 right side. If you send 8 right side, it becomes what? X minus y is equals to 16 minus 8. So we can cancel 8 ones are 8 twos are. Now it becomes x minus y is equals to 2. So this is the relation between x and y. Now we have to find a point on x-axis, which is equal distance from A and B. When the point is on x-axis, the y coordinate will be 0, right? So let's take, if y is equals to 0, then what is the x value here? X minus y is equals to 2. X minus y value 0 is equals to 2. So x equals to 2. So the point on y-axis, x-axis, sorry. Therefore, the point on x-axis is 2 comma 0. X coordinate 2 and y coordinate 0. Next, let's find the point on y-axis. So if point is on y-axis, we have to take y coordinate 0. So x coordinate 0. If x is equals to 0, now from this one, x minus y is equals to 2. Substitute x value 0. So 0 minus y is equals to 2. So minus y is equals to 2. If you send y right side and 2 left side, becomes minus 2 is equals to y. Otherwise y is equals to minus 2. So the point on y-axis is 0 comma minus 2. Therefore the point on y-axis is 0 comma minus 2. Next, 30a question is, what is the 30a question here? Prove that the following trigonometric identity. So what is the trigonometric identity given here? 1 plus cosec a whole by cosec a is equals to cos square a whole by 1 minus sin a. So let's prove it. So what it is given here, let's write here. So it is required to prove 30A question, right? So we have to prove that 1 plus cosec A whole by cosec A is equals to cos square A by 1 minus sin A. Yes. Let's take LHS first. So what is LHS here? 1 plus cosec A whole by cosec A. So we know that we can write this cosec A. Cosec A can be written as 1 by sin A. So 1 plus 1 by sin A whole by. So this cosec A can be written as 1 by sin A. Here multiply this 1 with sin A by sin A to make denominators equal. Sin A by sin A plus 1 by sin A whole by 1 by sin A. Now this one will be equals to sin A by sin A plus 1 by sin A whole by 1 by sin A. Now here denominators are equal, so we can add the numerators directly. So that means you'll get sin A plus 1 by sin A. Now reciprocal of this into sin A by 1. Now we'll get here sin A cancel. Now we will have it is equals to sin A plus 1. Otherwise we can write it as 1 plus sin A. So here LHS is equals to 1 plus sin A. Now let's take RHS. So what is RHS here? So this one. So here RHS is equals to cos square A by 1 minus sin A. So we know that the identity, trigonometry identity, first trigonometry identity. What is our first trigonometry identity? Sin square A plus cos square A is equals to 1. If you send sin square A right side becomes what? Cos square A is equals to 1 minus sin square A. So in place of this cos square A, we can write this 1 minus sin square A. Let's write. So 1 minus sin square A by 1 minus sin A. So this can be written as, this one can be written as 1 square minus sin square A whole by 1 minus sin A. Now it is like, now this one is like a square minus b square. So a square minus b square is equals to a plus b into a minus b. So we can write this 1 square minus sin square A as 1 plus sin A plus b into a minus b, 1 minus sin A whole by 1 minus sin A. So here this 1 minus sin A, 1 minus sin A gets cancelled. Now this will be equals to, this RHS will be equals to 1 plus sin A. So LHS is equals to 1 plus sin A and RHS is also equals to 1 plus sin A. So here we got LHS equals to RHS. Therefore LHS is equals to RHS. Hence proved. Next 30B question is, let 2A plus B and A plus 2B are acute angles such that sin 2A plus B is equals to root 3 by 2. Tan A plus 2B is equals to 1. Find the values of 4A minus 7B. So sorry, find the value of cot 4A minus 7B. So to find cot 4A minus 7B, let's find this A value, B value, then we can find that. So write what is given first. So it is given that sine of 2A plus B is equals to root 3 by 2, and tan A plus 2B is equals to 1. What we have to find? We have to find cot 4A minus 7B is equals to how much? So let's find it. So let's take this first one. What is the first one? Sine 2A plus B is equals to root 3 by 2. So at which angle in sine we get root 3 by 2? Sine 60, right? So sine 2A plus B is equals to, in place of root 3 by 2 you can write sine 60. So if you compare left side and right side, sine common, next to 2A plus B is equals to 60. So we will get 2a plus b is equals to 60. So let this equation 1. Now take the second one, this one. So what is that one? Tan a plus 2b. So it is given that tan a plus 2b is equals to 1. So we know that tan 45 degrees is equals to 1. Tan a plus 2b, so in place of this one we can write tan 45 degrees. So if you compare left side and right side, what do we get here? This a plus 2b is equals to 45. A plus 2b is equals to 45. So let this equation 2. So let's solve it by elimination method. So let's eliminate a first. Here, to eliminate a, the coefficient of a must be equal. In equation 1, coefficient of a is 2. But in equation 2, coefficient of a is 1. So we have to multiply equation 2 with 2 to make the coefficients equal. So equation 1 as it is. So equation 1 as it is. Equation 1 we have to multiply with only 1 to make it as it is. So 1 of 2a plus b is equals to 60. So this is equation 1. And equation 2 is, this equation 2 we have to multiply with 2. Now it becomes what? 2 of equation 2. What is that equation 2? A plus 2b is equals to 45. Now, so this will give us 2a plus b is equals to 60. Now this will give us 2 into a, 2a, next 2 into 2b is 4b is equals to next 2 into 45, 90. Now do subtraction. Sign, change the signs. So this is minus 2a. Now this is also minus 4b. And this is minus 90. Now add. Plus 2a minus 2a gets cancelled. Now plus 4b minus 4b will give us minus 3b equals to next plus 60 minus 90 will give us minus 30. So left side minus right side minus gets cancelled here. So this is B, right? Capital B. Yes. Send 3 right side. Now B is equals to 30 by 3. 3 ones are 3 tens are. So B value is 10. So to get A value from, we have to take equation 1 or equation 2. Let's take equation 1. From equation 1. So what is equation 1? 2a plus b is equals to 60 degrees. Here in place of b write 10. 2a plus 10 is equals to 60. And now send 10 right side. Now it becomes 2a is equals to 60 minus 10. Now 2a is equals to 60 minus 10, 50. Send this to right side. Now a is equals to 50 by 2. Now a is equals to 25. cot 4a minus 7b. So cot 4a, 4 into 25 minus 7b, 7 into 10. So cot 4a is 100, 7 into 10, 70. So now 100 minus 70, cot 30. So cot 30 is reciprocal of sin 30, right? Cot 30 degrees, we can write it as 1 by tan 30 degrees. Tan 30 is 1 by root 3. So which will be equals to root 3. So cot 30 is root 3. That's it. Next 31st question is, what is the 31st question here? In the adjoining figure, xy and x dash y dash are parallel tangents to a circle with center O. So here this xy and this x dash y dash are parallel tangents with the circles with center O. Next, another tangent AB touches the circle at C, intersecting xy at A, x dash y dash at B. So there is one more tangent, this AB, which will touch this xy tangent at A, x dash y dash tangent at B. So next, prove that AB subtends right angle at the center of the circle. So this AB will make 90 degrees at the center. So this one we have to make prove it is as 90 degrees. Angle AOB is equals to 90 degrees. So this one we have to prove it as 90 degrees. So let's try to prove it. So let's draw the diagram again. So this is one tangent and this is another tangent, and this one is one more tangent. So xy tangent, this is a x dash y dash tangent. Now this is AB and this is O is the center of the circle. The point of contact here is C. PQ is the diameter, right? So here we need to find, we have to prove that this angle at O is 90 degrees. So this angle at O is 90 degrees. So for that, let's do one thing, join O and C. Let's join O and C. And because of that, we have some triangles here. So what are the triangles? So this triangle and this triangle, this triangle and this triangle. Okay, so let the angles on this PQ, let us name it as, let the angles on PQ, there are four angles, 1, 2, 3, 4, right? So now let us take the triangle AOP, AOC. So this one, AOP is one triangle and AOC is another triangle. In triangle AOP and AOC, let's compare this. In triangle AOP and triangle AOC. So next, PA is equals to PC. Why this PA is equals to PC? They are the tangents from external point. PA is equals to PC because they are tangents from external point. Sorry, PA or AP. AP is equals to AC. So lengths of tangents from external points are equal. So they are the tangents from external point, they are equal. Tangents from external point. So next, this OA is common. So OA is equals to OA. It is common in both the triangles. And next, OC is equals to OA because they are radii of the same circle. OC is equals to, or we can write it as OP is equals to OC because they are radii of the same circle. So three sides of the first triangle are equal to three sides of the triangle. Therefore, these two triangles are congruent. Triangle AOP is congruent to triangle AOC. This is by triples congruency. Triples congruency. So we know that when the triangles are congruent, their corresponding parts are equal. Means their corresponding angles are equal, their corresponding sides are equal. So therefore, you can write here angle 1 is equals to angle 2 because they are corresponding parts of congruent triangles. Angle 1 is equals to angle 2. Anglet O is equals to anglet O. Here anglet O is 1 and anglet O is 2 here. So angle 1 is equals to angle 2 because they are corresponding parts of congruent triangles. Similarly, we can prove these two triangles are congruent. What are the triangles? Triangle BOC and triangle BOQ. So we can prove these two triangles are congruent and then we will get angle 4 is equals to angle 3. Similarly, we can get angle 4 will be equals to angle 3. Sorry, yes, angle 4 is equals to angle 3. In the similar way, we can prove it. Okay, so let this equation 1 and let this equation 2. Now add equation 1 and 2. What do we get here? Add equations 1 and 2. What is equation 1? Angle 1. Equation 1 LHS is, sorry, not equation 1 and 2. Add all the angles 1 and 2. Add equation, sorry, add the angles. Angle 1, angle 2, angle 3 and angle 4. Add all these four angles. What do we get? Angle 1 plus angle 2 plus angle 3 plus angle 4 equals to 180 degrees. Why? Why they are all equals to 180 degrees? Angle 1, angle 2, angle 3, angle 1, angle 2, angle 3 and angle 4. They are on the straight line. So therefore, their sum is equals to 180 degrees. Right. Now, replace this angle 1 with angle 2 because angle 1 and angle 2 are equal. So in place of this angle 1, you can write angle 2, one more angle 2. This angle 2 as it is and this angle 3 as it is, and replace angle 4 with angle 3. So because angle 4 is equals to angle 3, you can write angle 3 equals to 180 degrees. So angle 2 plus angle 2 is equals to 2 times of angle 2. Angle 3 plus angle 3 is equals to 2 times of angle 3 equals to 180 degrees. So 2 times of angle 2 plus angle 3 equals to 180 degrees. Send to right side. Angle 2 plus angle 3 equals to 180 by 2. So we can cancel, right? 2 ones are 2 nineties are. So therefore angle 2 plus angle 3 is equals to 90. What is angle 2 plus angle 3 in the figure? So in the figure, angle 2 plus angle 3 is equals to angle AOB. So this total is angle AOB. So therefore, in place of angle 2 plus angle 3, you can write angle. Therefore, you can say that angle AOB is equals to 90 degrees.